Shunt equation. Do you know that your right heart pumps blood into the lungs to make them well oxygenated? Do you believe that there are certain amount of blood does not participate in the gas exchange, just simply escape from pulmonary artery to pulmonary vein without participating in the gas exchange? That is called shunt. The amount of blood does not participate in the gas exchange called shunt. Today I am going to show you how much of blood in your lung does not participate in the gas exchange, just simply escape from pulmonary artery to pulmonary vein. This is your alveoli, where your oxygenation is happen. This is your venous blood, pulmonary artery. This is your pulmonary vein, which drain into the left atrium. So, amount of blood come through the pulmonary artery is called QT or total flow, QT. It is venous blood. It contains venous blood. So, amount of oxygen present there is called CVO2, venous oxygen amount. Amount of blood which does not participate in the gas exchange called shunt. Here, blood does not participate in the gas exchange, does not contact with the alveoli, does not participate in the gas exchange. So, that is called QS. QS or shunted amount. It also contains venous amount of oxygen. Venous amount of oxygen. The remaining part, that means Q total minus QS, remaining part go through your alveoli and well oxygenated. At the end of the capillary, at the end of the alveolar capillary, it contains CC end capillary amount of oxygen, end capillary amount of oxygen, CCO2. Then they go to the pulmonary vein where they mix together. The amount of flow is here again Q total. Here Q total minus QS. Here QS was this QS coming to this side. The total flow become again QT. Amount of oxygen present in your arterial blood or pulmonary venous blood is called CaO2. You can simply check by doing arterial blood gas. Arterial amount of oxygen, the amount of present there. Now I am going to calculate. How much of blood going through your lung without participating in gas exchange. Total amount of oxygen delivered to this side. Total amount of oxygen delivering into the pulmonary venous system must be equal to amount of oxygen here plus amount of shunted oxygen. I will tell you again. Total amount of oxygen delivered to the pulmonary venous system QT into CaO2 must be equal to, this must be equal to this amount and this amount. This must be equal to QS into CVO2 plus QT minus QS into CCO2, end capillary oxygen amount, CCO2. Then I am going to make this equation more simpler. So QT into CaO2 equal QS into CVO2 plus, I am going to multiply this one, QT into CCO2 minus QS into CCO2. Now I am going to take this QC1 into this side. Once you take this QC1 into this side, it becomes positive. So QS CCO2. This one, I am going to take this one and this one into this side, QS into this side. So this one become negative, it become minus QS into CVO2. Then I am going to take this one into this side. So it already containing QT into CCO2 minus Qt into CaO2. Now from here I am going to take Qs into the outside. Both part contain Qs. Then I can take one Qs into outside. So I am going to take Qs into outside. So within bracket what will contain CCO2 minus CvO2. Here also I am going to take Qt into outside, but both part contain Qt. So Qt I am going to take into outside. So within bracket CCO2 minus CaO2. Now I am going to take Qt into this side and this whole part into that side. So Qs and Qt equal, this side contain CCO2 minus CaO2 divided by CCO2 minus CvO2. Here CaO2 means arterial oxygen amount. You can simply do an arterial blood gas and check it. CvO2 means mixed venous oxygen. Again, you can do what venous blood gas. Ideally, it should be mixed venous blood gas. You can calculate it. But unfortunately, this part means end capillary. Here, at the end of the alveolar capillary, you have to take blood and calculate, check it. But it is not possible. So this part we are going to take from alveolar gas equation. We are going to take from alveolar gas equation. I am going to rearrange the equation now. So it will become like this: Qs and Qt equal. Here for this word I am going to put the amount I am taking from the alveolar gas equation. So CiO2 minus CaO2 divided by CiO2 minus CvO2. This is how you are going to calculate Shunt fraction. If you want to multiply it from 100, you can take percentage of Shunt. What is your usual normal percentage of Shunt? It is about, if you are healthy individual, it is about 5 to 10%. I will tell later how to calculate alveolar gas equation. That's all regarding how to calculate Shunt fraction. Bye bye.